Welcome to my channel Siprotec. Today we will see how to configure input-output masking and CFC in Siprotec Relays. So let's start. So in this video is going to be a bit lengthy because here we are going to cover both the input-output masking as well as the CFC. As the CFC and input-output masking are interlinked, therefore they need to be covered in the same video. So we are going to do that. Now first of all, in case of configuring input-outputs in any relay, we need to prepare an Excel sheet. Now input-outputs are basically what? These are basically the digital inputs which we are going to receive for the relay, as well as the digital outputs which the relay will give, such as the relay output as well as the LEDs. So we need to configure these things. So while configuring, first of all we need to prepare an Excel sheet where systematically we will show which inputs will be used for which function as shown in this Excel sheet. The 7 Opto inputs will be allocated. Similarly, output relays of the Siprotec relay will be used for different functions as shown in the Excel sheet. So similar way, LEDs will be available for these functions. So total 14 LEDs will be used, 20 outputs will be used, and 7 inputs will be used. And beside, you can see I have some places I have written CFC. There we are going to prepare the CFC logic also. So CFC logic are made where the configuration is not available in the input-output masking. So where this logic functions will not be available in the input-output masking directly, in that case we can prepare some logical some logic through CFC. So as you can see, we are first starting it with trip circuit supervision, and here I am considering the two inputs, that is input 1 and input 2 as per the Excel sheet. I am assigning both the input, that are the inputs which will give the signal to the relay that the breaker is in pre-closed condition or post-closed condition. And then there are internal logic inside the relay which will give the subsequent output. Then next is the teleprotection. In the teleprotection, we are configuring the distance channel received. When there is any fault in the zone 1, then a distance channel is received from the other end, and that will be received in that portion. Then in the power system data 2 also we are configuring some inputs, as you can see. Carrier received, carrier fail is made, then CB ready. Circuit breaker ready. This is the input which we receive from the circuit breaker, that is if there is any failure in the SF6 gas pressure and etc. In that case a signal comes to the relay that CB is not ready. So that we will get in the power system data 2. in the power system data 2 you can see that there is a CB ready option, CB healthy, circuit breaker healthy. Now while configuring the inputs, we just need to right click and click on high or low or not configured. Three options are available. So when our logic is such that the logic will be active when the output is input is high, so in that case we are doing this. We can also make the logic as the functions will be active when the logic is low. We can also make that, but in most of the cases we do the we assign the high because the input signal which comes from the field becomes high to the relay, and in that way it works. So as you can see, the input configuration are all done. Now the output configuration, that is, we need to configure the output for single phase trip. Now single phase trip we will first configure in power system in distance general, where the distance trip for L1, L2, L3 will be configured in 3 different outputs, because these are single phase output which will operate when the fault is in zone 1 and is a single phase fault. In case of single phase fault, the air is going to operate, so we will consider the single phase tripping, and that will be done through this single phase trip relay. A single phase trip command will be issued to the circuit breaker. Now in case of output configuration, you can see we have again 3 options: latched, unlatched and not configured. So in case of output relays, generally latching functions are taken, and in VT fuse fail or like that, broken conductor, in those cases unlatched functions are considered. Latched means once the signal comes or once the output becomes high, the output will remain high in the output of the output relay unless and until we reset the relay. And unlatched function is that when the output becomes high, the output relay becomes high, and as soon as the output of the relay becomes low, the output, binary output, also gets reset. So according to the Excel sheet, one by one we are going to assign the binary outputs. Now this process of configuring the input output masking is more or less similar in all Siprotec relays. The only difference is that in different relays, like in differential relay the logic is different, in distance relay the logic is different, in overcurrent earth fault relay some other logic comes into play. So in this way the logic changes, but the process of configuring the input output masking is same for all Siprotec relays. Now as we are configuring it on a template file which we have earlier configured, So there are predefined configurations which we don't need as per our Excel sheet, and therefore we are removing those things. Or modifying them accordingly. Yes, for single phase stripping you need to keep the output unlatched. This is because if we keep it latched, then the output relay or the single phase master trip relay will not get reset. That's why we are using the unlatched function in case of single phase stripping, and for three phase stripping we will use the latched function. So we need to keep the single phase. This is the thing which we should keep in mind, that for single phase stripping we must keep the output unlatched, otherwise the relay will be in set condition once the fault is there. As the fault got removed or the breaker has interrupted the fault, then also it will be high, and therefore the AR signal will not operate. So these are the three phase strippings which need to be configured for the three phase tripping relays. So all the zone 2, zone 3 faults or phase to phase zone 1 faults we are going to configure for the zone for the three phase tripping relay, which will, because there we don't need any auto reclose operation. And for zone 1 fault, single phase zone 1 fault, we need auto reclose operation. That's why we have used single phase output. Now we will go to AR block, auto reclose block, and we need to configure the auto reclose outputs. Okay, one distance operated function we need to give. This is for annunciation. This is an annunciation function which will give an annunciation on the panel that different distance relay has operated. Now you can see in the auto reclose function we will use basically three things. One is the AR output, which will close the breaker after auto reclose. One AR close command will be issued to close the breaker after a single phase fault on zone 1. Then there are AR lockout, that is if it is a zone 2 or zone 3 or zone 4 fault or any phase to phase fault, then we don't need auto reclose. So then an auto reclose lockout command will be issued, and whenever an AR close command is issued, then one annunciation must also come on the annunciation board of the panel that the feeder is under auto reclose or the auto reclose has operated in the feeder. So it is very easy to configure this input output masking. Just you need to have an idea that how the things are arranged in this input output masking. You can see in the above toolbar that there are two sections. One is source, another is destination. So in the source there are inputs, and destination there are outputs, and outputs have two parts. One is LED, another is binary output. Binary output is for the output relays. Now in measurement supervision we have VT fuse fail and broken conductor. So for this we are going to use unlatched function, because VT fuse fail may be temporary, it will come and go away. Then carrier signals will be configured in the teleprotection tab. Inside the teleprotection system we will configure for carrier fail, carrier send, and carrier received. So carrier fail will be when there is no signal, there is a carrier healthy input which comes to the input part of the masking configuration, as we have configured just earlier. So that will show, so that will activate this channel, that whether the PLCC system is okay or not. So if it is not okay, then it will give a carrier fail signal to the annunciation board through this output. And carrier send will be done, or the carrier will be sent to the other end whenever there is an fault and the relay has operated in zone 1 on single phase fault. Then a carrier send signal will be sent, and this carrier send signal, this output is going to the communication panel. It will make a high signal to the communication panel, which will then get transmitted to the other end. And the next thing is the power swing block and trip circuit fail. So when there is a power swing in the system, then that will also give an annunciation to the annunciation board through this output. And in case of trip circuit fail, trip circuit supervision, if both the inputs of the trip circuit which we have earlier configured is not high, and if any one of them is high, then it will be okay. If both of them are low, then this high signal will show that the trip circuit has failed, or there is a problem in the trip circuit. Now aided trip we will configure in the later part of this video through CFC. Now aided trip is that the 80% zone is covered in the zone 1, and the rest 20% of the 100% line will be covered through aided trip. That is, the rest 20%, it is zone 2 for this end, but it is zone 1 for the other end. So when the carrier received signal is obtained along with zone 2, then the time of operation of the relay reduces and an aided trip output is given. So binary output configuration is almost completed. Now let's start allocation of LEDs. As we have done it for binary outputs, in the similar way, there you can see a column for LEDs, and the available LED number will be shown in the above numbering, and the LED which we want to configure, we just need to assign a latching or unlatching, whichever function we want for that LED. So first three LEDs will be for distance strip R phase, Y phase, B phase as per our scheme. Then we are configuring for power swing PSB. Okay, first three LEDs we will configure through CFC, that's why we haven't taken it here. And we need to remove all this because these are the default configuration which are there in the template. So we need to remove this one by one and configure it as per our Excel sheet. That is zone 1, zone 2, zone 3, zone 4. These three will be available in distance general, as you can see. So the zone 1, zone 2, zone 3 and zone 4 tripping will be assigned first, both for single phase, multi-phase. Now one very important thing to say is that in case of any relay, whether it is a Siemens make relay, whether it is a MyCom relay of Alstom made, Areva made or GE made, or ACL relay, whichever may be the manufacturer, there are basic two things, two part in the relay. One is the setting part and another is the logical part. So I have made all my videos according to that structure, that there are two ways to configure a relay. First we need to configure the setting portion, and then we need to configure the logical portion. So in all relay, most of the relays, the both this part are available in two different segments or in two different form. And there is one third part also, which is the communication part, which is also available in all relays, and that is 61850 communication protocol, which is done through 61850 communication protocol, that is goosing. Now in case of this Siprotec relay, after configuring this, I will also make a video that how to make a goose communication between two Siprotec relays in the next video. And as we have made a complete video on how to configure MyCom relays and how to configure Siprotec relay, So later I will also try to make a video on goosing of two different relays, two different make relays, means one MyCom relay and one Siprotec relay. So we can also goose between two relays of different manufacturer. So I am going to create a video on that also. Now after LED configuration, we will start the CFC configuration. For that, first we need to right click and click on insert group, and the group will be a user defined group. In this group we need to insert certain informations. First of all, we need to insert the things which we need, that is, we need a single point function from enunciation, and just drag it on the table. So we for 3 LEDs we need to configure 3 LED and one edit trip function. So for that we need to insert 3 information. So 3 for 3 LED, 3 single point for 3 LED, and 1 single point for 1 edit trip function. So that means through these user defined functions which we have added, we are going to create an output, either in binary output we can create or in LED. Here what we are going to do is for LED only. So this outputs, these user defined outputs will be used to trigger the concerned LED. So let's rename these user defined outputs. So that is R phase strip, Y phase strip and B phase strip, one by one. This is the short text, and beside that you can write the long text also. You can copy and paste it to the other part. Just need to change the phase. So as many as logic you want to create on CFC, you first need to put them in the user defined tab. So in this user defined segment you need to put the number of single point or double point or whatever function you want, and create CFC on that. You need to first write them down, or you need to first include them in this user defined section, and then you can see we are going to configure the inputs and outputs for the CFC. CFC is basically the logic, the background logic which we will create. And suppose for distance strip A, B, C, now what we will create is that whenever there is a distance strip pickup for R phase, Y phase and B phase, as along with that, when there is a distance general trip, then the R phase output will be high, or Y phase output will be high, or B phase output will be high. So as you can see that these outputs will be done in the source tab. So in the source tab you can see there is a C part, and this C is basically the CFC function. This C denotes the CFC function. On both sides, on destination side there is a CFC function, on the source side there is a CFC function. So for the output, whatever we are going to take, we need to configure the CFC function on the source part, and the input which we want for these outputs will be configured on the destination part. So the pickup and the general trip, as you can see, will be configured on the destination side CFC. This is a thing to be kept in mind, that whatever output we want will be on the source side, and whatever input we want to give in the CFC logic will be on the destination side. So as you can see, I am taking distance pickup for phase 1, phase A, phase B, phase C, and one general distance trip, and one general distance trip. So these 4 functions I will use for this LEDs, and other functions which I need for the edit trip is distance trip zone 2, distance trip zone 2 single phase as well as multi-phase, and distance trip in zone 1 extension, as well as distance received from the other end, distance channel received from the other end. These 4 functions we need for edit trip to create the logic for edit trip. Now this is the basic input and output configuration is done to create a CFC logic, and then we need to save this. Distance channel received for edit trip will also be configured. And now let's save it and move on to the CFC function. Okay, let's assign the LED also first of all to these outputs. Edit trip on LED number 12. Okay, that's all done for the input output matrix. So now we don't need to open the input output matrix. So in work of the input output matrix is completed. Now we will straightway go to the CFC logic. In the CFC logic, these are the things which are already there for already there as per default configuration, so you need to delete this, and we will create a fresh CFC logic. Just right click and click on new, insert CFC chart, and double click to open this CFC. Through this object properties you can change the name of the CFC. So we will create two logic for CFC, one for LEDs, phase wise LED, and another for aided trip. So let's first make the phase wise LED trip logic. So this is the basic screen which comes in a CFC editor. So there will be two parts, as you can see. One on the left side will be the input, and on the right side will be the output. So first of all we need to take a logic block from the left hand side. There are various blocks. Whatever logic we want to create, that can be created. There are arithmetic blocks, basic logic blocks, and a number of logics we can create through these blocks. So first of all we are going to take 3 AND gate, because our logic is if both distance pickup, single phase distance pickup and general distance strip both are high, then the output of the LED will be high. Output for the phase wise LED will be high. So in 3 of these blocks, 3 of these AND block, we are going to connect one phase wise pickup, one phase wise distance pickup, and one general distance strip. So when both of them are high for any of the block, then that phase LED will glow. So we need to just click on the X1 or X2, whichever we want to connect. Just right click on that and click on the interconnect address. So we have already created it on the input output masking, so it will come in this list. Once we create it on the input output masking user defined section, it automatically comes in this list. So as you can see, we have connected the left hand side, and now in the similar way we are connecting to the right hand side. So on both the left hand side and right hand side you can see the input and output to which the block is connected will be shown. So in the similar way it will be done for all the 3 phases. So through this CFC we can create any logic we want, and that is not available in this in the input output masking. So this is all done for the LED configuration of phase wise tripping. Then we need to compile it. We need to compile it on the chart. Once it is compiled, there is no error, and then compile. And now the logic is uploaded on the setting. So whenever we upload these settings to the relay, automatically this CFC chart will also get uploaded to the relay. Now let's create the next chart, that is for edit trip, and in the similar way we are going to rename it. Now renaming is very important because otherwise it becomes haphazard that which CFC chart is for which function. So in the similar way we are going to connect the various blocks for edit trip. So here we have 3 functions which will be connected through OR and 1 function through AND. So we need 2 logical blocks, one is AND and one is OR. Now here are 2 functions, so we can go to the object properties and change the number of inputs. As you can see here, we need 3 inputs. So we are going to change the input. From here, number of inputs we are going to change. You can see we got 3 inputs and then one AND block. Now the output of this OR block will get connected to this AND, and another distance channel received function will be connected to the AND gate. So I would like to receive your comment, your suggestion on the videos I make for you, that whether these are beneficial for you or not, and any other kind of relay settings or protection related videos you want, you can write that in the comment box so that I will try to make a video on those suggestions. So this is actually a learning process. Protection is such a vast subject in power system that there are lot of things which need to be studied. While doing this video, I do also learn a lot of things, and you can feel free to give any suggestion or give any comment which can improve my videos, and also I can learn something from you people also. Now one block to another block can be connected directly. There is no need interconnect address in case of connecting one block to the other block. So the logic is completed. So in this way you can completely configure any Siprotec relay as per your requirement. And thanks for giving your precious time to watch this video. Thanks for your cooperation. So let me know how the videos are helpful to you or not. That's all for today, and subscribe the channel for the next video you are going to get. Thank you.